our notes are beginning here. So this is Unit 1. Unit 1 is all about linear functions. That was the very first one that you guys graphed on that function family worksheet that I gave you, was the straight line. So the whole unit is about that. Today's lesson in particular is just going to focus on solving equations involving linear functions. I'm going to say solving equations and inequalities. This is not an Algebra 2 topic. This is a review topic. But that's okay. It's a very important topic, and I want to make sure everybody's got it. Yeah, what's up? Yeah, these are our notes. So you want to keep all your notes in your first section of your binder. And I won't collect your binders until our very first test. So, all right. So that's the thing. So that's our objective for the day: is solving equations and inequalities. So first of all, let's start off with a key question here. What is a function? You guys can write anything I write. You can write more than I write if you like, but what I put up here you probably should have, unless I say otherwise. So what is a function? Well, basically, a function, it has a fancy definition that I think isn't very helpful. So I'll give you a definition that I feel is more helpful. A function, basically, in this class is going to be like an equation where you plug a number in and you get a number out. Okay? Oops. Okay, so suppose I have f of x equals x squared, right? Well, I can plug a number in, right? So pick a number for me to plug in. 2. Okay, so somebody said we want to do an input of 2. I want to plug 2 in for x. Okay, so what that looks like is like this. Now, what is 2 to the second power? It's 4. That's my output. So I plug in 2, I get out 4. If you ever have an equation where you plug one number in, you get out 2 different answers, which is possible, that's not a function anymore, just so you know. It has to be one answer. Okay? But that's what a function is. Okay? F of x is just a fancy way of saying y. So this would have been fine too. Okay? But that one over there is what we call function notation. You guys learned about function notation last year in Algebra 1? Yeah. All right. Can I proceed? No objection? All right. So part B. What is a linear function? Because remember, we're learning about all kinds of functions this year. And this chapter in particular is about linear functions. So what's a linear function? It's a function where the x has a power of 1. A function where the x has only a power of 1. So for instance, on the last one I gave you guys, y equals x squared. Is that linear? No, because the power is 2, right? That's actually what we call a quadratic function. Let me give you an example of a linear function. Y equals 2x minus 3. Look at your x. What's the power on there? It's not there, right? And when it's not there, that means it's a 1. So that would be a linear function. Okay? All right. So today we're going to be focusing on solving equations that are linear. Okay? So here's an example for today's objective. If y is 5, what is x? So take this equation here, right? I'm saying y is what? So I'm going to replace the y with 5. And you guys solve for x, right? You don't have to right now. Good.
A equals 2x and you divide the end of 4x.
Great mental math. Very good. So you get answers 4, right? All right. So I'm not going to solve this one, but you're right. You're 100% right. But the point is that this is a linear equation because the x has the first power, and we're going to solve for x. That's what we're doing today. All right? Just practicing that. Now, we're going to start here, and we're going to build up to the ones that look kind of crazy, so don't worry. All right. So, can I proceed, or is somebody still writing? Still writing? Okay, I'll pause for a second. Let's start with as simple as we can get here. Example 1. I'm going to call these one-steps. One-step equations. So, if I have x minus 5 equals 3, you guys can just shout out here. Okay, what do I need to do to solve for x?
Add 5.
Add 5, right? So the idea is I want to get x by itself, correct?
Yeah.
So I want to get rid of, on this side, I want to get rid of this 5, right? So the x is by itself. And that, to get rid of it, we do the opposite, right? So the opposite of minus 5 is plus 5. But whatever you do to one side, you have to do the other, because this is an equation. We want to keep it balanced. Oh, you know what? I mean, you don't have to be this picky, but I like to keep things straight. So x equals 8. And some of you guys probably just look at this mentally like, what minus 3 equals 5? Oh, well, you know, that's fine. All right. I don't care how you do it. It's kind of nice to know the algebra steps, though, because when we get into the harder ones, if you don't know those operations, you might have trouble. So it's kind of nice to know it. How about all right.
Divide 3 and it becomes x equals 5.
Yeah. You good? All right. 1, 2, 3. How's about
Those are 1 under 3.
okay?
And then A equals.
Okay. Yeah. So that's what I do too. There's different ways to do this. Some of your guys' teachers probably last year said multiply by the reciprocal. Is that kind of ring a bell?
Yeah.
That works. I don't personally like that idea. I like doing what LaFontaine just said. She said multiply by 2. And in other words, multiply by the denominator only. So here's what I mean by that. So we're going to multiply this side by 2, and we're going to multiply this side by 2, right? Now this 2, you can think of that as 2 over 1, right? And what do you do when you have a 2 on the top and bottom? Yeah. And so we're left with 1x equals
5. Oh my god, 6.
And then 1
Oh.
times x, do we really need the 1? No. So the answer is 6. Let's do another one. How about number 4 here? Let's say I had 2/5 x equals, I don't know, 20. What would I want to multiply on both sides? 5, the bottom number, right? So I'm going to multiply, I'm going to rewrite it just so I can see my original problem. I'm going to do times 5 times 5. So what happens over here? The 5's go away. What am I left with? And how about over here? That's going to be 100. Now what do we do? Divide. So I treat this one like a 2-step equation. You guys see I had to do 2 steps. I had to multiply by 5 and divide by 2. But some teachers teach it as a 1-step because they just say multiply by the reciprocal. In other words, you'd multiply both sides by 5/2, which is fine. You can do that. It's just that I like this strategy because it works in other situations better. So I just like to stick with this one. But you can do it however you like. Why don't I throw a couple of questions at you guys? Hi. Cool. Why don't you grab that spot, and I'll be right with you. So we'll call that number 1. Number 2.
What is SP1?
Oh, sorry. Student practice.
Oh.
Sorry. Yeah, that's new. I should have said that. 2x equals 10. Let's say 4x equals 5. And, oops. Number 1, Gabby, what was number 1? It was 9 equals? Cool. So what did you do? That's correct. You could have written it like that, or maybe you wanted to switch it in the beginning. Either way is fine. All right. Annalise. Who's Annalise? Annalise? No Annalise? Must have changed classes maybe. Or how about Raquel? Raquel's here. Hi Raquel. What was the question for number 2? All right. And so what did you do?
Divided 10 by 2 and
Good. And what did you get? Cool. Nice job. Is Vanessa here? Oh, that's okay. What's the equation?
1 half x equals
4. Okay. Like this?
Yeah.
Okay. So what did you do?
I multiply both sides by 2.
Times 2. Times 2. Are you sure that's number 3? Is that what you guys had for number 3?
That's number 4.
That's number 4?
Number 3 we got 4x.
I'm looking at the wrong one.
That's okay.
Oh my gosh, I was looking at the example.
Oh, okay, no problem. What? Because I was when I was checking people's work, that one didn't ring a bell. What was number 3 then, Vanessa?
4, I was like, oh, I'm just completely mixed up. 4x equals 5.
All right, cool. So what did you do for that one then?
Divided both sides by 4.
Cool. And what did you get as your answer?
X equals 5 over 4.
Good. You guys just leave your answer like that, okay? The only exception is if you need to reduce, you should reduce. I saw some of you guys write your answer like this. It's fine, but in algebra, it's usually not helpful. And some of you guys did this. This is kind of helpful, especially if you want to graph. If you like decimals, that is helpful. But really, just for the sake of ease, just that's good enough. Just make sure you reduce. You know, so if it's reducible, you should reduce it. All right. Let me come to Henry, what was number 5? Was it, no, 4?
1 over 5x equals 2.
And what did you do?
I did multiply, that's like 1 over 5 by 5, and then the same thing to the other side. And then I got 1x equals 10.
Cool. And we don't need the 1,
Yeah,
right?
so x equals 10.
So we're good. Nice job. Number 5. Kayla. What was number 5, Kayla? Where are you? There you are. Do you remember the equation? No? Okay. Natalie. What was the equation?
Negative 8 equals 3 over 7x.
Cool. What did you do here?
I times negative 8 and 7.
So we multiply both sides by the bottom number, right?
Yeah.
So here, this 7 and that 7 would cancel, and I'd be left with 3x. And over here, you'd get negative 56. Right? What would we do next, Javier? Where's Javier? Hi, Javier. What would you do next? Cool. And after that, you have x equals negative 56 over 3. I don't think they have anything in common to reduce out, so you can just leave your answer like that. Okay. So those are one-step equations, except this last one here. That's kind of like a two-step because of the way I do it, but that's that. Let's move on to some two-steppers and see how you guys do with those. Say that again? I'm good with using the back, yeah. If you don't want it, that's fine, but I'm good with it. Okay, two-step equations. Ready? I'm just going to call on you. I feel like you guys probably know. All right? But if you don't, it's okay. Just say, I don't know. That helps me. So, Alexis, what would you do first on this? Okay. Let me try. I'll try 3 people. If 3 people say I don't know, then I'll walk you through it. How about Kiana? Okay. Good. And then Danielle, where's Danielle? Hi, Danielle. After we add 5, what would you do? Okay, good. So you guys are right. So now here's how I want you to think about it if you're feeling a little bit sticky with this stuff. Ready? We want to get what by itself? X. Okay, so what's this 5 doing to the x? It's being subtracted. What's the 9 doing to the x? It's being multiplied. So to get rid of those numbers, you're going to do the opposite. So we're going to add 5 and divide by 9 on both sides. All right. So how would you get rid of the 5?
You would add 5 to 12.
Good. And then how do you get rid of the 9? Divide. Right? So now here's the question we haven't answered yet, though. How do you know which one comes first? Well, adding and subtracting is easier to do first, so I would just do adding and subtracting first. Okay? So you're right. To get rid of the 5, we're going to add it on both sides. This goes away, right? Bring down your 9x. Bring down your equals. 12 and 5 makes 17. No, you guys were good. I'm just making it probably too complicated for some people, but I'm just trying to slow down in case somebody needs help. How about, and we said how are we going to get rid of the 9? And I said it's okay to leave it like this, so long as it doesn't need to be reduced. Cool? I'm just making numbers up here. All right. Where's, oh, Heidi, I know Heidi. Hi, Heidi. What do we do first? Well, I don't know if I should ask the questions more slowly. What do we do first? Okay, good enough. Thank you. 14?
Yeah, you're right.
Cool. All right. Vincent. Are you Vincent? You don't want to tell me? That's okay. All right. So can I walk you through something though? All right. So what is this 6 doing to the x right now? Is it adding, multiplying, dividing, or subtracting? Yes. So when it's right next to it, that means they're being multiplied, right? What's the opposite of multiplying? Dividing. Okay. And that's how we're going to get rid of it, because we want to get that x by itself. So I'm going to divide it. Here's how you show division in algebra. You make like a fraction. Right? You're going to put 6 on the bottom. But, and whatever you do to one side, you have to do to the other, correct? So in this case, what is 6 divided by 6? 1. So you could put 1 if you want to, or you can not and just cross those off, right? And then we have 14 over 6. Now, that answer is right, but we do need to reduce that, right? What goes into those two numbers?
7 over 3.
2 does.
Yeah.
So if you divide the top by 2, you get 7. The bottom by 2, you get 3. So Henry, right? The answer is 7 over 3. Okay. All right. Can I push a button? Yes or no? Did somebody say no?
No.
We're good? My question should be clearer. All right, let's see. I think you guys can handle one more thing before I let you practice. How about negative 2 over 3x plus 1 equals 4? Hey. No cussing. That's like foul language. 7 minutes. I made a bad joke. Just like you know.
Oh,
Just like-
leaving you. I get it.
Yeah. Okay, what do we do, John?
Oh,
You want to get rid of the 1? Good. Right? So we always do that adding, subtracting first, right? With a 2-step equation. And we've done this already, right? So we're going to multiply, right? And what are we going to multiply by? So multiply both sides by 3, right? What happens on this side? Close. It leaves you with negative 2x, right? Don't forget about your negative. And now what? So what is this negative 2 doing to the x? It's multiplying it. So how do we get rid of that? We do the opposite. Now it's tempting to plus the 2, huh? Because that looks like a minus, but it's not. It's a negative. It's actually negative 2 times x. So the opposite would be dividing by negative 2. Notice that how the negative's on the 2, but look at my answer. I just put the negative in the front. Usually when you have a fraction, you could write it as a negative on the bottom or top, but typically you just put it in front. Okay? All right. So since there's only 7 minutes left, maybe 6 now, why don't you guys practice this and then we'll call it a day. So that's 1. I'll keep it small numbers so we don't go too crazy. All right, there you go.